I got quite a few, and I don't know how many pounds. I have to go count it up. And I still keep forgetting mine at home in my nice little, like, reusable grocery bag that's off to the side and not by the door. Anyway, I'll get it in. What's weird? I already kind of stated it, but in your guys' words, what's weird about this thing? No functions, but what are you given? You're given stuff up here. But what's your objective? Can you guys grab out a colored pen, please, please, please? This is a super important type of problem. It's not the exact same necessarily as other ones that you'll see, but it's very, very similar. You guys have seen some of these in homework, I think, and I want you to make a point of where you're first. Maybe even write yourselves a note. In every single one of these types of problems where it gives you clues but does not give you functions, you can't just go doing the deriving process right away. But you see these points, you see these clues, and you're like, yay, I get to play with the numbers. Is the answer 6? Is the answer 0? Is the answer 0? Is the answer 0? Is the answer 5? Is the answer 2? Is the answer 3? Does anybody see where I got those combinations from? I'm like, do they get added? Maybe. Do they get multiplied? Maybe. Do they get... Okay, right? But guess what the multiple choice answers are going to be? 0, 2, 3, 5, 6. So how do you know which one's right? It's all coming down to the word find. This is the objective. You can't get stuck in the clues. You got to keep focused on prize. You got to keep focused on where you're supposed to be aiming. But here's this trick. Or here's another tricky part of this problem. What is this? F of G. Remember last year, pre-calculus? You didn't like it then either. What would be another way of writing this? I'm getting to the formula, so hold on to that. That's exactly where I want to go, Janelle. But first, what am I trying to take the derivative of according to this? What am I trying to take the derivative of? I'm not going to the rule yet. Good job that you're thinking the rule. But what is being derived here? F of x such that x equals, it's not times, it's of 0. This notation from last year, you didn't like it then, you probably won't like it now. This composition notation is the exact same thing as this, taking the derivative of f of g of x such that x equals 0. So the very first thing we have to do before we ever deal about the 0 is, if I were you, once again, highlight, to think about the derivative of the general function first. Whenever they give you clues, never go to numbers first. Never, ever. Make a note of it in your colored pen. Never go to the numbers first. Always go to the function. Always go to the derivative rules or the integration rules. So, Janelle and AJ, you were both trying to tell me the derivative rule for this guy. What is the derivative rule? F prime of g, I'm going to put of x. Agree that that is the correct derivative rule for taking the derivative of the composition of functions f of g of x. Me too. But we're supposed to be finding this derivative such that, so then don't go plugging in numbers. Don't go to the clues yet. You have to have a place to plug them in first. Plugging in 0 just where the x's are. Now what am I ready for? The clues. You should not have even been thinking about limits until you have a place to plug them. Think of them in your handy-dandy notebook, and you're not allowed to open it until you need them. Because if you pull them out too early, you're going to get in trouble. Okay? So who gets plugged in? G prime of 0 can be. Who else gets plugged in? G of 0. And what's G of 0? And now what? F prime of 0. 6. It gets tricky if you don't legally follow the steps. So what did I do? I read the problem. In my mind, I saw the clues and I disregarded them. In my mind, I saw the clues and I disregarded them. I kept looking for what was most important. I didn't let myself get distracted in any of this. Good life lessons. That's what my devos this morning. Don't get distracted by this. Don't get distracted. Go to the main goal. The main goal. This is what you need to do. You need to find the derivative of the composite function f of g of x when x equals 0. Okay, composite function, do that first. Okay, fine. When x equals 0. Okay, fine. Now, when the timing is right, go look at the clues. Plug it in, plug it in. Now, this problem is actually a little easier than AP problems would be. This one is. Let's all together work on this one down here. Because the one up above, you had exactly the clues that you needed, no more, no less. Look at the table. You have all kinds of clues. Now, first of all, how do you read the table? What is 5? Someone tell me what equals 5. F of 3. Does that make sense? F of x when x is 3. So 5 is f of 3. So what's negative 2? F prime of. What's 4? Okay, does that make sense? Okay, so we're giving all the clues. But just a heads up, guys, whenever you're given a table, some of the things are important and some of them aren't. We're not going to be using all the numbers. So don't even try thinking of all the different combinations. Do we have clues? Yes. What do I want you to do to them? Disregard. Put them in a notebook, off to the side. If you haven't watched Blue's Clues, go watch a YouTube video this weekend. You'll know what I'm talking about. Take all the clues, disregard them, put them away. Stay focused on the main goal. What's the main goal? Where is it? But who's that guy? Don't tell me any. Okay. Right? Pause. I want you guys to get me a rule. And after you get me a rule, I want you to plug in at what x you're supposed to be finding or solving. And then just maybe you can unlock those clues and find the ones that you need. Maybe, just maybe, you can find the right clues. Discernment is really hard when you're so distracted trying to figure everything out all at once. Especially if you have no set rules to how you view life. But if for a problem at hand, you try to break it down to its elemental pieces, go to what you see as your foundation of truth. Look for any rules that might be involved. Maybe what to do and how to do it will be a bit clearer. Right now, there's so much stuff in this table. There's tons. Who gets multiplied by who, added to who, and we have to stay focused. What did you guys write down as your rule? Yeah, it's the exact same one as we just saw. The notation was even easier in this one. We didn't have that weird F-O-G thing up there. But we're supposed to be finding F prime of who? I'm only allowed to plug the 3 in where the X appear, right, cool kids? Did you get there? Did you go to your table and find what you needed? How many of you guys are like, this problem doesn't seem too bad? Good. Because guess what kids miss a lot? these types of problems. They get stuck here, and they don't remember there's a bigger goal that they're supposed to be focusing on, with rules attached that will point them very clearly to what they're supposed to be using. What's GP? But what's that 5 still within? Do you see why there's a 5 now? What's G prime of 3? Now what's F prime of 5? Are you going to get tricked? Hopefully not. Does it make sense though? Don't get stuck in the clues. Whenever you see clues, what do I want you to do? Disregard them until the proper time. Okay? Can they get distracting? Oh yeah. Can you get overwhelmed? Mm-hmm. Can they get distracting? Oh yeah. Can you get overwhelmed? Mm-hmm. But the problem, at least on the calculus exam, I can't always say in life, but at least on the calculus exam, and frequently in life, there will be set truths that you need to remember that will help guide where you're supposed to go. Ooh, okay. Why are we going to notes? Because I'm not exactly sure how much time we're going to have. Bless you. My goal is to check homework at the end of class. My goal, and to see how chain rule went. But as you guys saw yesterday, there are some more formulas in section 2.4, and that's what homework number 12 is about, 2.4b. So if worse comes to worse, we'll be checking 2.4a and b on Monday, okay? Okay. And some of you guys that were able to take pictures of your attempt by today, that's perfect. That was the deadline. You don't want late credit. But maybe you had some questions that you got a little stuck on. So maybe you have a little more time this weekend to try to perfect them if we don't get to grade it today. And then bring it on Monday for questions. I'm letting you guys get the title before I zoom in, because when I zoom in, the title's going to get lost. So derivatives of logarithmic and exponential functions were the second half of 2.4. I think it should have been 2 sections, so I made it 2 sections. I'm like, well, there you go, 2.4a and 2.4b. And on this page is everything pre-cal to do with logs. Not everything, but the very, very important things for calculus. You guys should have the title by now, I think. We're going to go through this kind of together, because I don't think you guys really need to get that far ahead. There's not a lot of writing to do, right? So question, what's a basic graph look like? Oh, I don't know log, I only know ln. ln's just a special log. What's a basic log graph look like? Yeah, Allie got it. Swoop, there it is, right? With the vertical asymptote at 0. The vertical asymptote at 0. Domain problem. X is greater than 0, which means logs do not exist if x equals 0 or negatives. Now, I'm saying x, but guys, couldn't it also be u? Ooh. I was using u last year. But you guys didn't know it was going to get applied to chain rule one day. I was using u last year with domain problems. 1 over u can't be 0. ln of u has to be greater than 0. Square root of u has to be greater than or equal to 0. Anyway. So right now I'm saying x greater than 0 because that's the argument, but really it's just the argument greater than 0. Or the argument will, if the argument is 0 or negatives, the log will not exist. But guys, help me with limits. What's the limit as x goes to infinity of any logarithmic graph of any base, including ln? Careful. As x goes to infinity, I'm going to the, and what's it going to keep doing, albeit slow? It's going to keep increasing. So the final limit is infinity. It does go to infinity, just super slow. Super slow. I think it even goes slower than square roots. Square roots go really slow too. Really slowly. Why don't I have the limit as x goes to negative infinity? Why is it the limit as x goes to 0 plus? Yeah, I can't go to negative infinity. My domain, if I were to write the actual like interval for this graph, wouldn't my domain be x is within infinity? So as I go to the right of this graph, I'm going to infinity. As I go to the left, well, I'm going towards the end point. That's a vertical asymptote. Anyway, where's my function going? Got it. Properties of logarithms. Reviewing the basic graphs. This point, any non-transformed logarithm is always going to have an x-intercept at 1. Because any log of 1 is always equal to 0. Because base to power, any base to the 0 power is equal to 1. So whenever you have an argument that equals 1, that's always a 0 of the logarithm. Why? Logarithmic to exponential. That was a thing in pre-cal. B to what power is 0? Sorry, b to the 0 power is what? Or b to what power is 1? The answer to that will always be 0. Some of you guys might remember from last year, we can undo logarithms with exponentials. That might be another way of thinking about it. 1 is equal to b to the 0. But what can I do when I have multiplication inside a logarithm? What's the property for that? Split them up. And what's the operation in between? Plus. Good. The sum of two logs, common bases, can be the product in one log. And a quotient in one log can be the difference, right? And last but not least, I might need you guys to grab out that colored pen again. And here's why. Some people get really confused with this last one. Can anybody figure out why? Based on what we've just done for the last couple weeks, why would someone get really confused about what's going on in property number 4 from pre-cal? What are you going to think now if something comes down? You're always going to think the power rule. But what's the problem? Is this deriving? No, this is just pre-cal. So I need you guys to somehow make a note to yourselves that this is not deriving. This is pre-cal. It's so easy to think that power coming down in a logarithm, something to do with the power rule, something to do with the derivative. And you guys should hopefully kind of realize in our rewriting and deriving, if you think the rewriting is a derivative, you're going to get really messed up. Or if you think the derivative is a rewriting, you're going to get really messed up. So you have to be careful. We can rewrite a logarithm. This is rewriting. This is not deriving. Maybe that's a better way of putting it. This is just rewriting. Does that make sense? It's not the power rule. And it's a struggle because you learned this first. It should be like, oh, that was pre-cal, not calculus, not derivative. But as soon as you power coming down, you guys have gotten so good at the power rule, hopefully, that your brain is just like, yay! But no, it's rewriting. Okay, yesterday, we talked about this because a few of you guys saw it in homework. The derivative of ln of x is 1 over x. What about common log of x? Let's not go there yet. Log base 2 or 3 or 7, let's not go there yet. ln, we love ln. Why? Because his rule is so nice and neat and easy. Last year, I was trying to push you guys to use ln more and more and more and more because his derivative rule is so basic. As soon as you go to another logarithm, ugh. We can memorize it, and we will, and we will be all right. But these ones are so much nicer. We're going to have a card for all the logarithmic and exponentials. Don't stress about making it. I want you guys just to try to use this rule. Can I zoom in on the problems? We're going to do the first two together and then have you guys play with the last two. So if the derivative of ln of x is 1 over x, then what can I do if I have y equals 5 ln of x? Any ideas? Yeah. But Allie, I'm going to mix it up. Is that Michael or Allie? Yeah, I thought so. I'm going to split it up just for a second. Is it okay, constant multiple? I'm going to leave the 5. Derivative ln of x is 1 over x. Are we good? But what can we do with 5 times 1 over x? Make it like Allie said. Got it. Not bad. Why is this one harder? Not impossible. But why is it harder? Product rule with an f of u inside. It's all right, though. Right? It's all right. Okay? How do we do product rule? I'm overwhelmed. Okay, fine. Just remind yourself, right? What's going on? Maybe it's too much for your brain to have to think about the product rule as you try to think about plugging in. So, okay, I got the rule. Let's go. What do I do with that guy? I'm going to say the rule. You guys are going to fill in what to do. Triangle. Box prime. Box. We're good. We have one more step. Triangle prime. Now, pause. Patricia and I just did mental math on that. Are some of you ready for mental math on that? Maybe, and maybe not. What did I do? I said, hey, I have a u. And we just use the rule 1 over u times u prime. It's not an f of a g of an h of a. We could just use the 1 over u times u prime. Like we use the u to the n, the derivative is n times u to the n minus 1 times u prime. Like the derivative of sine of u is cosine of u times. Exactly. So I just saw a u. And once you learn this rule really well, you're like, oh, derivative of ln of u is just 1 over u times u prime, without all the complications of simplifying. Now, or of writing it out, sorry, the long way. What would my final answer be? Is anybody else looking? An x can come out, but that's about it. An x can come out, but that's about it. So then y, oh, y. I'm going to move this down just a little bit. Ignore those examples for right now. We're just simplifying. Y, oh, y. Could this be? Y, oh, y. Could this be my final answer? Why, oh, why could this be my final answer? What happened in between? Pull out an x, and what do you get here? Pull out an x, and I get 5, and x can make the 5x over, but what happened here? Rewrite. What happens when you have a number in front of a logarithm? What can happen to it? Rewrite. So we have to have all those pre-cal properties ready to go. You guys, on your marks, get set, try number 2 and 4. Go. Try number 2 on your own. And once you think you have an answer to number 2, collaborate with your groups and then work together on number 4. That's just my advice anyway. Maybe follow it. Might be helpful. My advice, try number 2 on your own. Check with your group to see if you guys all have the same answer once you have an answer. And then keep working together on number 4. And I'm going to go get my f of g of h matryoshka. You're welcome. What can I say except welcome? Don't be lost. How about number 2? How'd we do?
Yeah, I got it.
Got it? 1 over u times u prime? Yeah. Simplified? Okay, so number 4. I think I'm going to do F and U and V. And let's see if this makes sense. Pause. Consider. If you don't like F and U and V, you can think of F and G and H. F of x would be tan of x. G of x would be ln of x, and V would be square root of x. H. Bah! Okay. How do I take a derivative? Everybody gets one, right? Yeah. But all in their own good time. But pause. Do we get how I decompose the function? So isn't it now supposed to be kind of easy as long as you know your rules? What's the derivative of tangent of u? Secant squared of u times u prime. Oh, yeah, that's right. What is derivative? 1 over times v prime. Oh, yeah. Times x prime. Oh, yeah. It's 1. Done. Is this correct? Yes. Is it done? No. Where are the x's? They don't have in Texas. So, question. What's this song? Not exactly the crowning glory of country music. But anyway, coming back. We get back to x's. So here's a strategy, just in case some of you are overwhelmed with plugging in. You could just theoretically work your way backwards. You could just plug in u first, I guess forwards. You could say, okay, secant squared of who? Secant squared of u, which is ln of v. Like you could just plug in the u first. Then you could say, okay, who's v? Oh, v's x to the 1/2. You could do it piece by piece. Some of you might be able to do it all at once. I rewrote this guy into rational form in the denominator, right? The negative popped him down. The 1/2 gave it a square root. Can I simplify? A little bit. What's the square root of x times the square root of x? So what do we end up with? Secant squared of ln of square root of x all over 2x. Dun, 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 dun. Boop. There it is. There it is. But the first step was decompose. Who's the outer? Who's the middle? Who's the inner? Yeah, AJ, what's up? Square root of x times square root of x is square root of x squared. Is square root of x squared, which ends up reducing to be x alone. Does that make sense? Okay, I want you guys to take 30 seconds in your groups and just check about people's clarification or check about people's understanding. Be like, does that make sense? It's going to be easier for you guys to answer each other's questions than for me to. Where did someone get stuck? Where did someone get stuck? Grace, what's Nona's club's name? BS? Oh, BS, yeah.
To be honest, yes, at first, and then I was like, okay. Let's go back to the basics. I thought that was the sign.
Oh, she already knows. Well, she said, can you remind your classes about Glee Club today? Like, oh, well. Which, what's kind of nice for you, though. You don't have to worry about. Hopefully they're both every other week, and they can, after this time, they can. I think the idea is just heightening awareness and appreciation. Is that like, I think that's the idea. Kind of like the, what was the one last year? Like the cultural club, sort of in the sense of like, hey, let's share culture, and then like anybody's welcome. Is that it? All right, is there anybody, you guys can keep going, finish your explanations, but is there anyone who's like, our group, I don't think we answered their question. Is there anything that needs further clarification from me? Okay. What if we have something other than log? I should say, sorry. What if we have something other than ln? What if we have something other than ln? Okay. Pre-cal. Ooh, pre-cal. Here's the idea. Guys, I can't let you talk if you don't come back. Come back. So we have a log that's not necessarily an ln anymore. Now it's just any log. It could be a common log base 10. It could be a log base 2, a log base 7, a log base 13, a log base who knows who. There is a change of base formula that says that we can change the base to any other log that we want, but we just have to follow very specific rules. But here's the dealio. We don't necessarily want to change this to any log. We want to change this to the rule that we know. So we're going to take this rule and apply it specifically to, hey, we can make any log into ln of x over ln of b, which is the same thing as 1 over ln of b times ln of x. And here's what I need you guys to make note of. This guy is just a constant. And if he's just a constant, that means he's not going to mess up the deriving process. He's going to be there, he's going to be present, but he's not going to mess anything up. So I can actually say, here's your forever card. For logarithms, we do know the derivative of ln of x is 1 over x. We do know the derivative of ln of u is 1 over u times u prime. Ironically enough, absolute value has absolutely no bearing for ln's only on the derivative rule. It's going to be the exact same. But as soon as we get to log base b's of x's and u's, we have to change just one little thing. We have to put 1 over ln of b times 1 over u, which is the same thing, times 1 over x. There's a constant that needs to come in when it's changed to ln. So we're actually going to end up rewriting it as 1 over x, just like ln of x, but with a little ln of b offset by a constant. And ln of u is very similar to log base b of u. You still have the 1 over ln of b, but times 1 over u times u prime, which we're going to simplify to be 1 over u ln of b times u prime. And that's all based on logarithmic properties. Now, kiddos, here's the dealio. I would love to do tons and tons and tons of other practice on logarithms, et cetera, et cetera, et cetera. But sadly, our class time for today is done. Now, we have good news and bad news. Good news is you can do most of 2.4b homework. Bad news is we've talked about logarithms, but not the other half of the title, exponential functions, which means this 2.4b homework is going to need to be due on Tuesday, which means our test on Tuesday is not going to happen. But we have, as you guys are packing, getting ready to go, but we have kids taking the PSAT on Wednesday. So our test is going to be on Thursday, the day after the PSAT. Kiddos are going to be gone for period 1, but guess what? On Wednesday, period 6, everyone's going to be here. So we're just going to be reviewing. It's just going to be a work day on Wednesday. So those of you guys taking the PSAT, you can either try to come in during period 6 and come in during their class, depending on what you have, or you can watch their video as a furthering of the review for the test on Thursday. Get out of here, kids. Thanks for letting me update your calendar. It'll be updated on my website by lunchtime. Chapter 2. 2:1 to 2:4. You don't want the end of chapter 2 on this test. You want it split up. Oh, any at all, huh?